Okay, so for this video, we will be discussing the derivative of logarithmic functions. So, for the derivative of logarithmic functions, so we have the following formulas. So, the derivative with respect to x of the logarithm of u to the base b is equal to 1 over u multiplied by the logarithm of e to the base b multiplied by the derivative of u with respect to x. So in this formula, so we have here the u. This is an arbitrary function, okay, representing any function of x, and then we have b, which is the base. Okay, so you have to review here your logarithms, okay, that you have learned from your previous mathematics. So we also have the derivative with respect to x of the natural logarithm of u is equal to 1 over u multiplied by du over dx. Okay, so recall that the natural logarithm is a logarithm with a base of e. Okay, so recall that your e, that is the natural base with a value of, actually it's in your calculators, so its value is, where's e? Not that one, is that the one? So e, we have, I don't know where, but if we have e, yeah, so it's e raised to 1. That's 2.71821, yeah, this value 2.7182818. Is this 8? Yeah, whatever. Okay, so that's the value of the natural base e. Okay, so recall that the natural logarithm is a logarithm to the base e. Okay, so therefore ln of u, so say for example we have ln of u that is equal to ln of u, that ln of u that is logarithm of u to the base e. Okay, so following this formula, so this should have a multiplier of logarithm of e to the base e, right? So but logarithm of e to the base e is equal to 1, so therefore there's no need to write it anymore. Okay, so again, so you have to review, okay, the properties of logarithmic functions. Okay, so because some of those properties may be used in the evaluation and simplification of the derivatives, okay, of the logarithmic functions. Okay, so let's see how we can apply these formulas. So for these examples, so we have the first one, find the derivative of f of x is equal to the logarithm of x squared minus 4 to the base 3. So let's just rewrite that here. So example 1, example A. So we have f of x is equal to logarithm of x squared minus 4 to the base 3. Okay, so again, for this type of logarithm, we will be following the formula. So the derivative with respect to x of logarithm of u to the base b is equal to 1 over u multiplied by the logarithm of e to the base b times du over dx. Okay, so obviously, sorry, we have so for this example, so we have, obviously our b will be 3, and then our u will be x squared minus 4. Okay, so therefore the f prime of x is equal to the derivative with respect to x of the logarithm of x squared minus 4 to the base 3. Okay, so following the formula, Okay, so following this formula, so our u obviously here is x squared minus 4. Okay, so therefore we will have 1 over x squared minus 4 multiplied by the logarithm of e to the base b. Our b is equal to 3, so therefore it's logarithm of e to the base 3, and then multiplied by the derivative of u with respect to x. So our u is x squared minus 4, so its derivative is, derivative of x squared is 2x, and then the derivative of negative 4 is 0. Okay, so because it's a constant. So therefore, the derivative, if we simplify it, so f prime of x is equal to, so we have here 2x times the logarithm of e to the base 3, so that's 2x logarithm of e to the base 3 over x squared minus 4. Okay, so this is our derivative. Okay, so all you need to do is follow the formula. Okay, so for our second example, so our second example, here we have h of x is equal to so h of x is equal to ln of x plus square root of x squared minus 1. Okay, so for this problem, so we will be using the second formula. So the second formula, so let's rewrite it. The derivative with respect to x of ln of u is equal to 1 over u multiplied by du over dx. Okay, so in this case, so our u is equal to x plus square root of x squared minus 1. So in the formula, since we will be needing the derivative of u with respect to x, then let us derive this. So d with respect to x, so du over dx is equal to 1 plus, so how do we derive this? So we can rewrite this in exponential form. So we have x plus x squared minus 1 raised to 1/2. Okay, so its derivative is equal to, using the general power formula, so multiply the exponent in the coefficient, so we will have 1/2 multiplied by, sorry, this is x squared minus 1, multiplied by x squared minus 1 raised to 1/2 minus 1, and then multiplied by the derivative inside. So the derivative of x squared minus 1 is 2x. Okay, so therefore our the derivative of u with respect to x is equal to, simplifying this, so we can cancel out 2, so it will be 1 plus x over square root of x squared minus 1. Okay, so therefore h prime of x is equal to the derivative with respect to x of ln of x plus square root of x squared minus 1. Okay, so which is following the formula, so we have 1 over u, so our u is x plus square root of x squared minus 1. So 1 over x plus square root of x squared minus 1 multiplied by the derivative of u with respect to x, so that is 1 plus x over square root of x squared minus 1. Okay? So we can simplify that. We can combine it into a single fraction. So multiplying 1 by this, so it will become 1 plus x over square root of x squared minus 1 over x plus square root of x squared minus 1. Okay, so we can eliminate the denominator, okay, in the numerator. So by multiplying the numerator and the denominator by square root of x squared minus 1 over square root of x squared minus 1. So distributing that, so h prime of x is equal to, so 1 plus square root of x squared minus 1. So that will be square root of x squared minus 1 plus, multiplying this in the second term, so it will eliminate square root of x squared minus 1. So therefore what will remain is x. And then multiplying x by square root of x squared minus 1. So it will become x square root of x squared minus 1 plus multiplying this square root of x squared minus 1 times square root of x squared minus 1. So it will eliminate the radical sign. So what will remain is x squared minus 1. Okay, so this is our derivative. Okay, so for our third example, so we have y is equal to square root of x ln of x. Okay, so this problem can be solved by applying the derivative of product. Okay, so dy over dx is equal to first term multiplied by the derivative of the second term. So it's square root of x times the derivative with respect to x of ln of x plus ln of x multiplied by the derivative with respect to x of square root of x. Okay, so performing the derivatives, so we'll have square root of x multiplied by the derivative of ln of x with respect to x, again following the formula. So here our x is equal to u, right? And then multiplied by its derivative. So the derivative is 1 over x multiplied by the derivative of x with respect to x, so that is 1 plus ln of x multiplied by the derivative of square root of x is 1 over 2 square root of x. Okay, so simplifying, so square root of x over x, that is 1 over square root of x plus this will become ln of x over 2 square root of x. Okay, you can also factor out square root of x, but I think this is this form is already okay. Okay, so next is we have letter D. Z is equal to the logarithm of x over x minus 1, okay, to the base 10. Okay, so this will follow the first formula. Okay, this one. So where our u is x over x minus 1, our b is equal to 10. Okay, so let's just write that again. So the derivative with respect to x of the logarithm of u to the base b is equal to 1 over u logarithm of e to the base b multiplied by du over dx. Okay, so again our u here is x over x minus 1. Its derivative with respect to x is equal to, using the quotient rule, so denominator multiplied by the derivative of the numerator. So derivative of x is 1 minus numerator, the derivative of x minus 1 is 1 over x minus 1 squared. Okay, so simplifying this will become x will be cancelled, I think. So it will become negative 1 over x minus 1 squared. Okay, so following the formula, so our dz over dx is equal to the derivative with respect to x of the logarithm of x over x minus 1 to the base 10. So this is equal to 1 over u. So this is our u. So therefore, 1 over u is equal to 1 over x minus 1 multiplied by log of e to the base b. So our base is 10. So times log of e to the base 10 multiplied by du over dx, which is negative 1 over x minus 1 squared. Okay, so simplifying that, so simplifying this, so 1 divided by x over x minus 1 is equal to 1 times the reciprocal of the denominator. So it will become x minus 1 over x multiplied by log of e to the base 10 multiplied by, negative 1 over x minus 1 squared. So as you can see, we can cancel out x minus 1. Okay, so what will remain will be negative log of e to the base 10 over x times x minus 1. Okay, so next example, so we have letter E, y is equal to ln of 5 plus x squared raised to 3 halves. Okay, so in this problem, so we can use the properties of logarithm. Okay, so recall that when we have ln of x raised to a, okay, that is actually equal to a multiplied by ln of x. Okay, so therefore this exponent actually can be transferred as a coefficient. Okay, so again, recall your properties of logarithm so that you can evaluate the differentials or the derivatives easier. So y is equal to, so bringing that down, so it will become 3 halves ln of 5 plus x squared. Okay, so in deriving this now, so dy over dx is equal to the derivative with respect to x of 3 halves ln of 5 plus x squared. So we have a constant, so we can write that outside the derivative. So we have 3 halves times the derivative with respect to x of ln of 5 plus x squared. Okay, so following the formula, so we will have 3 halves multiplied by 1 over u. 1 over, our u is 5 plus x squared. Okay, multiplied by the derivative of u with respect to x. So the derivative of 5 is 0. Derivative of x squared is 2x. Okay, so as you can see, we can cancel out 2. So therefore, our derivative with respect to x is equal to, so 3 times x, so it will be 3x over 5 plus x squared. Okay, so for our 6th example, so we have find the derivative of x is equal to ln of x plus 1 times x minus 1 squared all over 2x minus 1. So in this problem, the properties of logarithm will be very useful, particularly the logarithm of product and the logarithm of quotient. So recall that the logarithm of the product of x and y is equal to logarithm of x plus logarithm of y. Okay, and the logarithm of x over y is equal to the logarithm of x minus the logarithm of y. Okay, so in this case it's ln, but they are practically the same because ln is just a logarithm with the base e. Okay, and if we have this case, so as you can see, we don't have a base. If the base is not written, then it is assumed to be 10. Okay, or it's not assumed, but it's known, okay, that it's 10. Okay, so applying this property in here, so you have here product and then quotient. So when we have product, it's addition. When we have quotient, it's subtraction. So x, therefore, if we simplify it, it will become ln of x plus 1 plus ln of x minus 1 squared, and then denominator minus ln of 2x minus 1. Okay, so next we have an exponent here, so we can transfer that in the coefficient side. So x is equal to ln of x plus 1 plus 2 ln of x minus 1 minus ln of 2x minus 1. Okay, so the next is apply the derivatives of logarithmic function. So dx over, sorry, what's this? It's dx over. Okay, so maybe I copied the problem wrong. Okay, so let's change this to y instead. Okay, so dy over dx is equal to, so all we need to do is derive this. So following the formula, it's the derivative of ln of u is equal to 1 over u multiplied by d over dx. So this will become 1 over x plus 1 multiplied by the derivative of x plus 1 with respect to x, that is 1, plus we have 2 multiplied by the derivative of ln of x minus 1, so that is 1 over x minus 1 minus the derivative of ln of 2x minus 1 is equal to 1 over 2x minus 1 multiplied by the derivative of 2x minus 1, so that is 2. Okay, and then simplifying, dy over dx therefore is equal to, multiplying this, so this will become 1 over x plus 1 plus 2 over x minus 1 minus 2 over 2x minus 1. So this is already this form of the final answer is already okay. So if you want to add those fractions, it's up to you, but this is already an acceptable answer, okay, for its derivative. Okay, so for the last one, we have an implicit function. Okay, so find dy over dx for y ln of x minus x ln of y is equal to 1. Okay, so that type of equation is implicit. Okay, so that is an implicit function, so therefore we have to derive this implicitly. Okay, so first one, y ln of x. So here we can apply the derivative of a product. Okay, so for the derivative of the first term, so we will have the first factor multiplied by the derivative of the second. So y multiplied by the derivative of ln of x is 1 over x multiplied by the derivative of x with respect to x, that is 1, minus, or sorry, plus ln of x multiplied by the derivative of y with respect to x, so that is y prime. Okay, minus the second term, so deriving this, so we have x multiplied by the derivative of ln of y, so it's equal to 1 over y multiplied by the derivative of y with respect to y, that is y prime. Okay, plus the derivative of, plus ln of y, second factor, multiplied by the derivative of x with respect to x, that is 1, is equal to, the derivative of a constant is 0. So simplifying this, so we will have y over x plus y prime ln of x minus x over y prime plus ln of y is equal to 0. So collecting the terms with y prime and the others transpose to the right side. So we have y prime ln of x minus x over y prime is equal to, transposing, negative y over x minus ln of y. Okay, so collecting the terms y prime, so y prime is multiplied by, so factoring y prime, multiplied by ln of x minus x over y is equal to negative y over x minus ln of y. Okay, so dividing both sides with coefficient of y prime, ln of x minus x over y. On the other side also, dividing it by the same, ln of x minus x over y. So this will be cancelled. So then y prime is equal to, so adding this, so we will have greatest common denominator is x. So x divided by x times y, so that will be negative y. x divided by 1 times ln of y. So that will be minus x ln of y over, we will also add the denominator. The greatest common denominator is y. So y divided by 1 times ln of x. So that is y ln of x. Y divided by y times x. So that is minus x. Okay. So to simplify this will become, this will become numerator multiplied by the reciprocal of the denominator. So this will become negative y minus x ln of y over x multiplied by reciprocal of this is, we have y over y ln of x minus x. Okay, so therefore, so we can multiply this now. Okay, but you can also leave it as that. So here we can factor out negative. So we'll have negative times y. So negative y multiplied by y plus x ln y over x times y ln of x minus 1. Okay, so this is now our final answer, okay, for the derivative of that implicit function. So sorry, there was a slight mistake. So we have x times y ln of x minus x. Okay, so this is x. Okay, so okay, so that's all for this video. I hope you have learned something, and then see you on the next lessons.